Similar to finding the arc length of a certain curve using single variable integration, we can find the area of a surface using double integrals. And the formula also look very similar. Instead of having one integral, we have two, or a double integral, and instead of having just dy by dx, we have to take account for both x and y, as the surface depends on x and y. So we will have partial of z over x and then partial of z over y, and both of them will be squared, just like in the case for single integrals or the arc length. Now let's look at a problem on how to apply this formula. So let's find the surface area of the part of the surface z equals x squared plus 2 twice y that lies above the triangular region T in the xy plane with the vertices 0, 0, 1, 0 and 1, 1. So if we sketch this out, well, we just need to find these 3 points and join them to find our triangle, which we call T. And this region is my domain of integration. Now all I have to do is integrate using this formula and we'll get the area of surface. So let's do that. Area of my surface, let's if my surface is called S, area of S is a double integral over the region T, 1 plus partial z by partial x plus partial z over partial y times dA. So here we can use that z equals to x squared plus twice y, and this means that partial z over x squared plus twice y, partial z over partial x is equal to twice x, partial z over partial y equals to 2. This means that this will become the double integral over the region to 1 plus 2x whole squared plus 2 squared dA. So this is then this is 4 plus 1 is 5, so we've got 5 plus 4 x squared dA. Now this integral will be easier to perform if we do the y integration first, because this expression is in terms of x. So if we want to do it with a y integral, then we're using a type 1 domain, where we first start a small vertical line from the bottom of our graph and move it up, and the first line it hits is my lower limit, which is just y equals to 0, because this is the x-axis, right, the lower line of this triangle. So this is y equals to 0, and as we keep moving this up, the second curve that we will hit is y equals to x. And for all the other points, we can also use the same arrow, and we can see that this type 1 covers the entire region, and we have to start our arrows from x equals to 0 and end at x equals to 1. We have to do the y integration first, setting the limits up in this way. So now this is just we have 5 plus 4 x squared times y, where we have to take the limit x to 0, 0 to x dx. This is just x minus 0, right? And so we can just write this as 0, 1, x square root 5 plus 4x squared dx. Now what we should note is that if we let this function be f of x, then the derivative of f is just 8x. That means if I bring out a 1 over 8 here and put an 8 over here, so that we still have the same thing, which is equal, this should be equal to 1, 8 by 8, and then this means that this is the derivative of my f, and if this is my f, this, and the integrals, if we want to do integrals of this type, we can simply do it quite simply. F of to the nth power of x, and f of derivative of x dx is just n plus 1 x divided by n plus 1 plus c. So here we're doing definite integral, we won't need the c. So this is just 1 over 8 is to the power half. F has a square root, so we have 5 plus 4x squared. Half plus 1 is 3 by 2, 3 over 2, and we also have to multiply it with or divide it by 3 by 2. Divided by 3 by 2 means multiplying with 2 by 3. So we have 1 over, oh yeah, we also need to care about the limits. 3, 12. 5 plus 4x squared 3 over 2. If we put 1 over here, then we have 5 plus 4 is 9, 9 to the power 3 by 2, minus 5, since if we put 0 it's just 0, so we got 5 to the power 3 by 2. I think this is our answer. We can take the square root here if we want. So we'll get 12. So the square root of 9 is 3. 3 cubed is 27. So we've got 27 minus 5 to the power 3 over 2. 5 to the power 3 by 2 is 5 cubed square root, right? So we have 5 into 5, and then we have another 5. This means this is just 5, so you put 5 root 5, so it should be 1 over 12, 27 minus 5 root 5. In the area of the paraboloid z equals x squared plus y squared that lies under the plane z equals 9. So let's first draw z equals to x squared plus y squared. So this is my paraboloid. Now we want to find this surface over here in a way that all up till z equals to 9 is covered. So I need to know what my domain is. Now you can think of the domain as if you shine some light, the shadow that will fall from the paraboloid, like the light is thrown vertically, if this is a torchlight, and this light is thrown vertically, so like all these points on which there will be a shadow, we need to find all of this this particular region. What is this region, all these points, and to find that, you can see from this diagram, this is just this entire circle. This entire circle is in fact the projection, the shadow that you're going to find in the xy plane. So this basically means that we have to find, since this circle lies on the plane z equals to 9, and we have to find this particular circle, this means that the paraboloid also intersects this plane in the same circle. So this means that z equals to 9 and z equals to parabola. If I intersect these two equations, I'm going to find the circle. So let's do that. X squared plus y squared equals to 9. This means this is equal to 3 squared. This is just the equation of a circle with radius 3. So we will do that. So we'll now draw our domain. Our domain is circular. So it has a radius of 3. So this whole thing can be written in the simplest way using polar coordinates, that is just r equals to 3. R constant value of r are circles with centers around the origin. So this is my domain D. Now all I have to do is calculate the area of my surface. So area of my surface equals to the double integral over the domain D square root 1 plus partial z by partial x whole squared plus partial z by partial y whole squared dA. So let's first find out, since the surface that we're interested to find the area of is z equals this parabola, right? So this parabola is z equals to x squared plus y squared, and its partial derivatives are just twice x and twice y. So this is just 4x squared plus again 4x y squared. Now we can take 4 common, and let's write the area element in terms of polar coordinates. So this is just r dr d theta. We still have to convert this into polar coordinates, and we know that x squared plus y squared is just r squared this is r squared r dr d theta. Great. Now we have to put in our limits. So our r limits, the entire region has the smallest value r at the origin where it's 0. There is no distance from the origin to the origin, and the largest distance that these points can have is 3 from the origin, because it's within the circle. It's either less than 3 or equal to 3 if it's on the surface, or something in between. So we have r equals to 0 from r equals to 3, and we have to cover the entire circle. So we start from let's say 0, and then we have to end all the way to make a complete circle at twice pi. So from 0 to twice pi our theta limits. Now it's simple problems, just calculating the value of this iterated integral. Now here's the interesting part. This is if we call this function f of x, then my derivative is 8r, right? Because 1 plus 4r squared, if I take the derivative of that, I get 8r. So I need an 8. So I put a 1 over 8 here and another 8 over here. So the 8 by 8 is just 1. So they are equal. And then this is just my derivative of x. Now we can use the same relation just as before, so that we can, we increase the power of f of x. Like if this function, which is the square root of 1 plus 4r squared by 1, so we get 1 plus 4r squared to the power 3 over 2. And we have to divide by 3 over 2, which is the same thing as multiplying by 2 over 3. And we now have to substitute the limits. Then we have to integrate again with in terms of for theta. So now it's after substituting the limits, we should simplify this a little bit first. So 8 into 2 over 3 is just 1 over 12, 0 to twice pi. And this is 1 plus 4 into 3 square is 9, 9 into 4 is 36, 36 plus 1 is 37, 37 to the power 3 over 2, and if I substitute in 0, you just get 1, that means minus, because it's the lower limit, and minus 1 to the power 3 by 2 is just 1, so you get minus 1 here, d theta. And once I do this part, I'll just get theta back, do this integral. This is just a constant, 37 over 3 by into to the power 3 by 2 minus 1 theta twice by 0. So, and if I do this integral, this will just give me twice pi minus 0, because the lower limit is 0, upper limit is pi. So anyways, so 1 over 12 times twice pi, and this is 37 root 37. This is the same thing as the 37 to the power 3 by 2 minus 1, and finally we get pi over 6 37 root 37 minus 1.